Good morning, ladies and gentlemen. We are glad to welcome you to the second edition of the webinar on Industry 4.0, which is co-organized by Steinbase and Smart Learning Factory from Germany. To start with, we will give a brief introduction of Steinbase activities. Steinbase is one of the largest value-adding platforms across the globe in terms of transfer of know-how from institutes to industry. So what we do and how do we add value is, on one side, we partner with businesses for different kind of projects, for providing them know-how and our expertise, and which helps in building competencies for companies, which ultimately helps in serving the society. Steinbase today has got more than 1,100 enterprises in its network. More than 2,000 enterprises have been established since 1983, and we do more than 10,000 projects every year. So how do we add value? Again, if we come to the details, any expert can become a part of a Steinbase network to deliver its services to the industry. It is something called as a company within a company, where you can actually, without establishing your own company, but you can operate a sort of an enterprise under the Steinbase umbrella, providing services to your clients. And the total network is totally decentralized within the Steinbase framework of rules and regulations. So the whole idea of Steinbase network is the whole is greater than sum of its parts. So together we may be small, but individually we may be small, but together we create a huge organization which is Steinbase. As I told you, we have more than 1,100 Steinbase enterprises, more than 20 in India, more than 2,000 employees, and 4,000 freelance workers engaged on project basis. The basis of trust revolves around Steinbase brand, and our motto is to add value to customers and partners with reliability and connectivity. How do we provide our services in terms of research and development, consulting, and training? Under training, we help in competence development for companies and employees. And one of the biggest strength of Steinbase is the Steinbase University Berlin today. I think on Steinbase University, my colleague, Mr. Ardin Jalali, will be covering more details in his presentation, which is coming next. So the total organization, the Steinbase network, is based on Steinbase Foundation. Steinbase Foundation is then established Steinbase GmbH and Company KG for technology transfer. Steinbase GmbH company has more than 1,100 Steinbase enterprises across the globe. And then it has got Steinbase partners, franchises, minority holdings, and so on. The strength of Steinbase is not in terms of number of centers which are providing services to its clients. The strength of Steinbase actually comes in terms of how much business we are able to do. That indicates the trust we are able to generate in the market. And in the year 2019, the total revenues of Steinbase was more than 170 million euros. As I already indicated, we have more than 3,471 freelancers, 637 professors, and more than 2,135 employees. The focus of Steinbase is on innovation and people. If you see the history, Ferdinand von Steinbase, who is considered the father of Steinbase, he was the chairman and Chamber of Trade and Commerce in the Kingdom of Württemberg. He was the initiator of dual education model. He was the promoter of technology transfer and development in Württemberg, and he was the founder of the first Steinbase Foundation, 1968-69 to 1923. Steinbase Foundation aim is to provide benefit to enterprises and their employees, as well as build bridges between science and academia on one hand, and the world of businesses on another. So we do it through various ways through Stein-based symposia, Stein-based media, Stein-based addition, enterprises, university, and other activities. In 1971, Stein-based Foundation was established. In 1983, Professor Dr. Johann Lohn embarked on his role as chairman of Stein-based Foundation Board, and he introduced the concept of transfer centers, which is known as Stein-based enterprises today. In 1998, Stein-based GmbH and Company KG for Technology Transfer was established. And in 2020, the network grew more than 1,100 enterprises. So there are various reference projects. We have many thousand projects which we have done over these years. This is just in brief about Stein-based. These are our contact details. This is for Stein-based Germany. This is for Stein-based India. And that's all from my side. Thank you. I invite my colleague, Mr. Ardin, to take over.
Thank you very much, Vinit. Ardin, could you please introduce Stein-based Germany to us? Thank you.
Yes, thank you very much, first of all, Lucas, and of course, Vinit, for inviting me to this webinar. I appreciate very much being with you. And thank you for the introduction about Stein-based. My name is Ardin Jalali, and I'm International Director at the Stein-based University and the School of International Business and Entrepreneurship. So one important pillar of Stein-based is the university, and what is our USP in this university, which is the biggest privately organized university with the right to award doctorates in Germany. And what is our USP is that we provide this dual system and work integrated system on the levels from vocational education training to bachelor, master, but as well to the doctorate level. And all our students at the same time are preparing throughout their studies an innovation project for a company. And this is as well our strength. It's the practical application and the implementation of really added value to our clients and companies. And in many cases, the companies are paying for the study fees of our students. We have very valuable partners in Lukas Merkel and Johannes B. Isa in their company. And they have a lot of experience with a legacy working, for example, with Fraunhofer in Germany, and they are following the same philosophy like Stein-based, and as well are lecturers for Stein-based University. And we are working as SAIB and Stein-based in 50 countries, and India definitely with our colleague Vinit Goyal is one of the important markets or partners for us, and we are really looking forward to extend our activities in India. And I think the best way to do it is with the activities of our friend Lucas, which he will provide to you today. Thank you very much for your attention, and I wish you a good webinar.
Just to add here, Adin, we have quite a few participants from across Asia Pacific, many participants from Bangladesh, Indonesia, Vietnam, Australia. So it is our privilege to welcome them all to this webinar.
Definitely. I have Iranian legacy. My father is from Iran, and so from that side, I'm participating in conferences toward Southern Asia several times, and I think there for Stein-based as well, very interesting to extend our activities there. And we have good partners already in Malaysia, for example, but as well on that side, there's a lot I think we can do together to close the gap between university, academia, and the industry, which is our mission. And there everyone is invited to join our network. Thank you, Vinit.
Thank you so much for the introduction, Adrian. My name is Lukas Merkel. I'm the founder of the Smart Learning Factory. We are a spin-off of the German Fraunhofer Association, and I'm going to introduce the Smart Learning Factory to you today. And today we're going to talk about the Smart Learning Factory, the virtual lab for Industry 4.0. And this is a proposal for Indian institutions, but also for all of the participants from the Asia Pacific region who are joining us today. And I'm going to give you a presentation about this virtual lab. And after the presentation, I'm going to give you a short demonstration about the online platform and about the projects the students can do. And later we will be open for your questions, and we're going to answer all of the questions you have. The presentation part of this video will be recorded and it will be put on YouTube afterwards. The Q&A part will not be put on YouTube. Okay, so let's start. So today we're going to talk about digital transformation, about Industry 4.0. And in this picture, you can see our learning factory in Augsburg, Germany. And the learning factory is a realistic manufacturing environment, and it can be used for training, education, but it's also used for research projects to develop new technologies. And the approach of such a learning factory is very hands-on. We use experience-based learning to develop the problem-solving skills of the students. And in this picture, you can see a learning factory we set up in the Switzerland Innovation Park in Switzerland. And in this learning factory, we are providing them facilities to educate the students in intelligent quality assurance, mass customization, or connected logistics. And in these learning factories, we use a lot of technologies. And in order to give you the chance to participate or to use a smart learning factory, we are bringing all those technologies online in a virtual lab, in the virtual smart learning factory. So you will be also able to bring those Industry 4.0 topics into your curricula at your universities. And in the Smart Learning Factory, we have 5 different main topics. And those 5 topics are cloud-based IT infrastructures, advanced manufacturing, artificial intelligence, virtual technologies, as well as tracking and tracing. And later we'll go into details. So what is the content of each topic? So here you can see, again, the Smart Learning Factory, which is like a real-world lab. We set it up in Switzerland, but we also use it with Steinbeis in Germany for training production managers in topics like paperless processes, transparent logistics, high variant assembly, or intelligent quality assurance. And last year, we also set up a lab at the Technical University of Munich, TUM, and the students will have classes in this lab from this year on. On the other side, we also did some virtual labs already, for example, with the Universidad RFID in Colombia. And we did several modules with them about paperless processes, KPI visualization, as well as artificial intelligence. And later, after this presentation, I will give you a short demo about our artificial intelligence project. So what are the requirements and the outcomes for the students as well as the partner universities? So in order to participate in the virtual smart learning factory, you need a stable internet connection, you need a computer or a tablet, webinar software, and it would be good if the university has some kind of existing equipment, but this is optional. This is not necessary for the virtual lab. The outcomes are the students, they will get an idea about the current topics of digitization, of manufacturing. They will know how to integrate different software tools. For the universities, this virtual lab is a benefit because they will be able to attract more students to the university and maybe even become a flagship university for Industry 4.0 in their region. So what about the requirements and outcomes for the students? So we are targeting students which are advanced, undergraduate, or already postgraduate students. So if a student just completed high school and is in his first or second semester at university, he's not in our target group. He should have studied at least 3 to 4 semesters or about 2 years at university and have some basic understanding about math, physics, engineering, and maybe some programming skills before he's joining the virtual lab. The ideal student is maybe a student who already is in his last year of his bachelor's degree or is in his master's degree, maybe already has some work experience, has some programming skills, and wants to advance on topics like Industry 4.0. This is like the ideal student for us. The majors we are focusing are engineering, mechanical, electrical, production engineering, but also electronics or computer science. It would also be able to include business students, but in order to include business students, they should have some basic understanding of manufacturing processes. Maybe they have 2 years of work experience in a manufacturing company or did an internship in a manufacturing company. So they have to be they need some basic knowledge about manufacturing when they are business students. And it's also a huge benefit if the students have some basic programming skills and have already written some lines of codes already. And they also should have good English skills because all of the content will be in English. So B2, C1 would be the English level we require from the students. The outcome for the student is that after his graduation, the student will be an expert in Industry 4.0. He will be able to implement such applications in a manufacturing system. And throughout the program, we can also give the students support to access international universities, German universities, show them how the application process works in Germany for the universities as well as for the companies, for example, internships or direct entries, training programs at German companies. And the student will also receive a certificate. This certificate will be jointly provided by us, the Smart Learning Factory, Steinbeis India, and Steinbeis Germany. So here you can see the 5 topics again of the virtual lab for Industry 4.0, cloud-based IT infrastructures, such as manufacturing execution systems, advanced manufacturing, like new technologies such as 3D printing, artificial intelligence. We're going to use that for quality control, for example. Virtual technologies like augmented or virtual reality are part of this program, and also tracking and tracing, for example, to use RFID to track logistics processes. And the methods we use in this program are aligned with the methods Steinmeier usually uses in his programs. So we have 25% self-study, 25% interactive case study. We have a project and a documentation with 25% each. And now I want to go more into the details about the duration and the structure of the program. So the program will take around 20 weeks for the student to complete. And the workload for the basic, for our entry-level course, is 100 hours. So in the first half of the program, which lasts 10 weeks, the student goes into the 5 topics I just mentioned. And in each topic, he will have 1 week for self-study and 1 week for the interactive case study. After the student completed the 5 topics, he will be able to choose 1 topic where he will do a project. And this project will be very interactive. In this project, the student has to work also on his own and develop something and really apply the knowledge he gained in the first half of the program. In the documentation part, he will summarize all his learnings and also give a presentation in the end. So each self-study and each interactive case study, which builds on the self-study before, will take about 5 hours for the student. But this is like a minimum we expect for the student. So if the student is motivated and wants to be successful, we strongly support that the student even spends more time than we displayed here on this slide. The project and the documentation take about 25 hours each, and it's up to the student how to organize himself and complete the project. The yellow part, the interactive case studies, they will be interactive, and the students will review the results of each other. So one student will review 2 case studies of his course mates, and he will also receive 2 reviews from other course mates before he is submitting his final solution of the case study. For our virtual lab, we're going to have 3 levels: an entry level, an advanced level, and an expert level. So at first, the student usually starts in the entry level. If he completes the course successfully, he can move up to the advanced level. When he completes the advanced level, he can go to the expert level. And on each level, we have different technologies in those 5 topics. So on the entry level, the student will get the basic ideas of Industry 4.0, such as manufacturing execution systems, 3D printing, knowledge discovery in databases, some basics about augmented and virtual reality, and some insights into current auto ID technologies. On the advanced level, we will go more into details, more into newer topics, such as IoT communication standards, such as OPC UA, MQTT. We're going to talk about human-robot collaboration. We go into detail about machine learning, object detection, object classification. In virtual technologies, the student will learn about authoring tools, about applications for VR training, and the student will go deeper into dashboards and KPIs. On the expert level, the student will gain insights about current cutting-edge technologies, such as time-sensitive networks, advanced planning systems, deep learning. We're going to talk about industrial blockchain applications and localization technologies, such as ultra-wideband or indoor GPS. So on the so if the student completes the expert level, he's ready for current research about Industry 4.0. All those three modules, the entry module, the advanced module, and the expert module, they differ in some cases, and the workload increases. So I already introduced the entry module to you with 25 hours of self-study, 25 hours of interactive case study, project and documentation. In the advanced module, we're going to add a little bit more. So we're going to provide webinar talks about current developments in Industry 4.0 with German or Indian companies, and the companies will give presentations, and there will be Q&A sessions with those companies. And the project will also be a little bit longer, and it will be a real-world project, and the task will be given by a German or Indian company. So this is going to be a real-world task and not just a student project. The total workload for the advanced module is a little bit longer. It's going to be 120 hours for the student. The expert module will be even longer. It will be 150 hours, and the expert module includes a 1-week visit to one of our smart learning factories in Germany, and the student will have a 1-week workshop and training in a smart learning factory in Germany. We will also have an application workshop with the student, so in order to help the student to apply for internships or master's programs or direct entries in Germany. So this is the expert module, which includes which also includes a 1-week visit to Germany. After this presentation, after this webinar, you will receive this presentation as a PDF, and on this slide you will later see the important dates. So we're gonna start the next batch for the virtual lab in the beginning of April, and it's possible for the student to start the virtual lab every 3 months. So we're going to start at the beginning of April, beginning of July, beginning of October, and beginning of January. And the program takes about 20 weeks. So if a student wants to go up to the next level, he can do it 6 months after he started the previous course. And there will be the first registrations will be possible from February 8th, and we will also give free access to the first topic. So students can register in 2 weeks from February 8th, and they can already have a look at the first topic and see how the quality of the materials is. So we don't want the students to pay for something he didn't see before. The student has to see what he gets, and if he likes the course, if he likes the quality, if he likes the topics, then he can choose if he wants to register in the course. And getting access to the first topic will be free from our side. There will be 2 partnership models for the Smart Learning Factory, for Indian institutions as well as for other institutions in the Asia Pacific regions. And we're going to call those 2 models the Model A and the Model B. And the difference is that in the Model A, the student is participating in the Smart Learning Factory, and the Smart Learning Factory, as well as Steinbeis India, is getting in touch with the student, is offering training, is checking the case study materials the student provides, and so the university of the student is not included in this project, and all the administration is done by Smart Learning Factory as well as Steinbeis. And we're also going to start with Model A in the beginning. In Model B, the virtual lab is more integrated into the partner institution, into the university. So in Model B, this program or this virtual lab is established at the university, and the training, the case studies are analyzed by faculty, by teachers, by professors of the partner institutions. And also the final presentation is given to the lecturers from the partner university. And also the administration of the students is done by the partner university. And in this model, this course can be an integral part of a curriculum of, for example, of a bachelor's degree. So in Model A, the student joins our virtual Smart Learning Factory, and in Model B, the Smart Learning Factory virtual lab is established at the partner institution, and they can start the course whenever it fits to the university schedule. In Model A, we have our own schedule every 3 months. In Model B, it will be exclusive only for registered students at the university. And so in Model B, our business partner will be the university, and in Model A, our business partner is the student directly. So we have a lot of details, and I'm going to talk a little bit about the details, but all those details are on the slide, and you will receive the presentation afterwards. So if you want to get more into the details, you can also read the slides afterwards. And if you're interested in cooperating with us or sign an MOU, then please get in touch with Vinit, and we will schedule a one-on-one meeting exclusively with you. So for the Model A, we are starting a course when we have around 50 students. If the students clear the entry level, they move up to the advanced level and later to the expert level with a visit to Germany. And so in the long term, our goal is also to provide a postgraduate program on Industry 4.0. The platform, the online platform for the Smart Learning Factory Virtual Lab is provided by us, and the certification is provided jointly by Smart Learning Factory, Steinbeis India, and Steinbeis University Germany. And so here you can also see the prices for the students with the 20% early bird discount already included. In the expert course, the trip to Germany, the flight ticket, transport, hotel is not included. In Model B, it's necessary to sign an MOU between Steinbeis and Smart Learning Factory. We're going to set up the basic infrastructure at the university. We will train 3 selected faculty members of the partner institution in a train the trainer seminar, and then the students register directly at the partner institution. And the training for the student is conducted by trained staff of the partner institutions, and we will provide IT support for the virtual lab. and Steinbeiß India, as well as Smart Learning Factory. We will provide the software, the access to the Smart Learning Factory online platform. We will do initial trainer workshops. We will do continuous support, and we will also still be able to offer a joint certification. So for the Model B, there will be a one-time fee for the train-the-trainer seminars and a smaller recurring fee for the students, which can be paid by the university, of course.
Here it is important to note that these fees are only towards Steinbeiß and SLF for the students. Universities can decide their own fees to be charged to the student for each courses.
Exactly. So, so on the model A, the price for the student is already defined, but for the Model B, the university can also see this as an opportunity and define their own prices for the students. And in the Model B, we also offer a visit for the senior staff of the university to Germany. And we already did this with universities from China, as you can see on this picture. And usually we do it for 3 days. And on Thursday, the faculty arrives in Germany. On Friday, we have a workshop in the Smart Learning Factory with MIU signing and a get-together, a formal dinner in the evening. On Saturday, we do some sightseeing. And on Sunday, there's the departure of the participants, so they're also able to extend their trip in Germany or Europe. So, so currently, due to this COVID-19 crisis, this is not possible, but once this period is over and international travel is possible again, we will also offer this again. For us, high quality standards are very, very important, and we take several actions to ensure those. We provide the certification, but there will be online quizzes, there will be final presentations where we check the project results. We have standardized grading schemes. The whole process is supervised by Steinbeiß India, and in Model B, we are also able to integrate our virtual lab with the assessment system of the partner institution. So this will be the presentation where I'm talking about the general concept, and now I want to go more into some details and give you a short demonstration about the Smart Learning Factory lab itself. So I'm going to show you our web page. It's going to be smartlearningfactory.com, and the students will be able to register in 2 weeks, and there the students can go into the different courses we offer, and one course where I want to go, or one technology where I want to go more into detail is our virtual, or one part of our virtual lab I want to show you is the artificial intelligence part. And in this artificial intelligence part, we're using TensorFlow, which is a machine learning platform, to analyze, or we're going to use that in quality control. So we will provide the student with the software, and the task of the student will be to develop a machine learning algorithm that will do a quality control of this remote controlled car. So for example, this car can be manufactured with different rim colors. So here we have 2 white rims, and on the other pictures we have a black and a blue rim. And the student will be asked to develop a machine learning algorithm with TensorFlow. And I can already show you the results of such a algorithm. So the student will use our technology and then develop this algorithm that detects the rims, detects the colors, and then there's a quality control if this remote controlled car is manufactured with the right rims. So here you can see there were two pictures, and now we have two more pictures which are generated by our machine learning algorithm. So as you can see, the algorithm detected the blue rim as well as the black rim. And here on this picture, it detected the two white rims. And we're going to provide this use case for the student. We're going to provide them with all the necessary training data to generate such a machine learning algorithm model. And then the student will be able to develop a quality control use case on his own with this remote controlled car. And he can use these skills also to develop algorithms for his own tasks or for the products of a company he will be working in. So we will teach the students, or we will provide the students with skills he can really use in the industry afterwards. And I want to show you one more feature of the Smart Learning Factory Virtual Lab. I already recorded this feature on video, so I'm going to play this video now for a few minutes. Excuse me, can you hear the sound of the video? Is it possible? So here we have real experience in our, so it's a virtual lab, but a real experience. And here you can see that the student is logging into our Smart Learning Factory lab in the browser, in the web browser, and he is accessing a cloud-based computer which is running on Amazon Web Services. And we have this real use case in a box here in Germany, and he can access the real use case. He can control the PLC and really work with real equipment without having to make an investment. So in this use case, we have this turning cloud, which is rotating, and we have different sensors, and the students can learn about different IoT technologies, different connection methods to access those sensors and analyze them. And so the advantage is that we have this experiment set up here in Germany, and students from all around the world can access it and work with real equipment on their own. They can do it from home, they can do it from the university, they can do it anytime they want, and they can all access it in our virtual lab. So, and the student is not able to destroy anything. So, we have a scheduling system where the students can also schedule a certain time where they want to access this demonstrator. And so, and this demonstrator, this technology will be part from the advanced level on. So we're going to offer this in the expert and in the advanced level of the program. The students will be able to control real hardware, all from home, and the university doesn't have to provide or finance any equipment. And finally, to complete this presentation, I want to show you a video about the Smart Learning Factory lab in Germany.
There's no sound, Lucas.
So in this lab, you can see the Smart Learning Factory in Germany, and where we do different courses. This is my business partner, Johannes Beiser. And here we have a group of production engineers who is visiting our Smart Learning Factory in Germany, and they are learning how to transform a manufacturing system from paper-based to paperless production. So here in this assembly workplace, you have seen a lot of paper, order sheets, assembly instructions, a lot of documents, and we are showing the engineers how to get rid of all those documents and transform this factory into a fully digital manufacturing system where we use tablets, RFID technology, manufacturing execution systems to improve the productivity, improve the transparency, and also improve the quality. And a visit to this lab is also part of the expert course. So the third level, the expert course, includes a 1-week visit to this lab where the students can work with cutting-edge software technologies in manufacturing and really get an insight about current developments in Germany, which hopefully will be really helpful for their career. So all those participants in our Smart Learning Factory in Augsburg were very happy and with the outcome, and we are hoping that we can meet you someday in our Smart Learning Factory or one of your students. And I want to thank you very much for the participation in this webinar. We have around 62 participants right now, and I'm very happy with that. The first webinar like this we already did in December was also very successful. Thank you very much for your attention,